7th graders, it's Mrs. Trembley. We are kicking off Unit 6, all about surface area. And before we begin talking about how to calculate surface area, we need to look a little bit at the figures we're going to be calculating the surface area of. And surface area is a little different than area. Surface area has to do with three-dimensional figures. So that's kind of what today is all about. A three-dimensional figure, it's called three-dimensional because it has length, width, and height, or sometimes height's referred to as depth. It's a solid. A polyhedron is a three-dimensional figure whose faces are all polygons. I'm sure you've heard the term polygon before. It's what a mathematician says when his bird flies away. Polygon. I know, not funny. They never are. Maybe it's funny that I continue to tell jokes that aren't funny. I hope at this point. Anyway, the first thing we're going to look at is the difference between a prism and a pyramid. I mean, in just looking at those two, I'm sure we can see how they're the same. I mean, they're both three-dimensional. We can see that. They're those little dashed lines to kind of show you, hey, this has depth as well. But if you notice, this one, they all kind of come to a point on top. And this one, it's not just one single point that they all come to. Maybe that's a difference you could notice. Well, here's the difference. With a prism's a polyhedron that has two parallel identical bases. And when we think about bases, I'm guessing you're thinking of bottom, top or bottom. This triangular prism isn't really set up on its bottom, and it's kind of hard to tell here. I'm going to get some highlighters out. Maybe you have some highlighters or colored pencils. You want to press pause and grab that. But it says that it has two parallel identical bases. So I'm going to look for what shape is, there's two of them, and they're identical. And if you look, I see this piece here, and this piece here, like the two sides and the bottom, those all match, but there's three of them. There are two triangles though. So even though this isn't set up on the bottom, doesn't have to be the bottom, this is still considered a base, and so is that. So two identical bases, that's part of what makes it a prism. And I want us to write the word base here so we can remember when we're looking back at what a base is. So two identical bases, so I can set it up on the top or the bottom, they're both the same. And then the lateral faces are parallelograms. So we'll see there's going to be some green here. This is considered a lateral face. And if you look over here, this is an identical lateral face here, and the bottom as well. I'm not going to color that one in, I think it's just going to be too much of a mess here. But all of these pieces here, maybe I'll just darken this entire thing in, that's considered a lateral face. Fancy word, I know. Just kind of talking about the sides, not the top and the bottom, the sides. This is called a triangular prism because when we identified the bases, they were both triangles, right? The shape of the base tells you the name of the prism or the name of a pyramid, which we'll talk about in a second. So this is called a triangular prism because the bases are triangles. In a pyramid, it's a polyhedron that has one base. So, and also, the sides are going to all come up to a point. So all the lateral faces in a pyramid, they're always going to be triangles. Here we see the lateral faces are parallelograms. They're not triangles. When you have a pyramid, the lateral faces, the sides, they're all going to be triangles, and the base is what's going to differ. So notice in this one, I only have one of the base. I don't have two identical bases. That's one way to tell. So that's the base, the one in yellow. And then maybe we can darken this in here and see that this is one of the lateral faces. Oops, lateral face. So all of the sides surrounding the base are all triangles. They all come up to a point. That's kind of the difference. And notice this is called a rectangular pyramid. It's not the faces that identify the name of it. It's the base. So this base is a rectangle. That makes this a rectangular pyramid. Hopefully so far so good. Alright, we're going to talk about two other shapes right now. I'm sure that you have seen them before. A cylinder and a cone. And these have kind of similar properties of prisms and pyramids. With a cylinder is a solid, it has two parallel identical circular bases. Take a look. Here's the bottom, here's the top. Those would be considered the bases because I have two identical circular bases. And I'm not going to refer to this as a lateral face. Lateral faces are parallelograms, and this, honestly, it's just one big rectangle that wraps all around. And I hope we've had time in class for me to open one of these cylinders up and show you. If I haven't yet, we will. So this right here, I'm not going to call it a lateral face. I'm just going to call it a lateral surface. Because in a lateral face, those are going to be parallelograms, and I need more than one thing, more than one face for it to be parallel to something else. Okay, notice the cone. A cone is a solid that has one circular base and one vertex. So a cylinder, there's a top, there's a bottom. In a cone, there's just one circle. So that's the base. The base is on the bottom if you're working with a party hat, and if you're having an ice cream cone, then that would make the base the top instead. Maybe you need to hit pause and go get yourself an ice cream right now. Or not. Keep going. Reward yourself with an ice cream when the notes are over. Okay, so here's what I want you to be able to do first. Look to the opposite side here. I want you to be able to identify whether or not it's a prism or a pyramid, and then tell me what kind it is. And remember, the base is what names it. So take a look. How do we do this? Number one, you're going to see if it's a prism or a pyramid. If it has two identical bases, that makes it a prism. So if the top and the bottom are the same, it's a prism. If it has one base and it comes to a point, it's a pyramid. So that's step one. Step two then, we just need to look at the base, and that's going to tell you what type of prism or pyramid it is. So look at this first one here. Make sure that you can see on there a little bit more. There we go. Okay, I'm not seeing anything coming to a point on this, and I know that these big sides, there's how many of those? 2 of those, and then we have these little things on the side. I guess I could pick anything to kind of be the base here. So let's just pick this and this. Do you see how the top and the bottom are the same? Yes, that makes this a prism. So I'm going to write the word prism above this. Prism. And I have to know what kind of prism. Well, this shape right here, it's a rectangle, right? This is a rectangle, so that makes this a rectangular prism. Rectangular. So that's a rectangular prism. Look at this next shape here. Okay, I see that I have a whole bunch of triangles around the side. Now remember, a pyramid, the lateral faces are supposed to be triangles. And I see, here's the bottom. And notice the bottom and top don't match. I don't have 2 bases that match. I just have one base here. So one base, and they come to a point. That makes this a pyramid. Now you have to tell me what kind of pyramid it is. So we need to know what this base is. Let's see how many sides that it has, because that's pretty much how you name a base. We have 1, 2, 3, 4, 5. There are 6 sides to this base. Do you remember what that's called? A 6-sided polygon? It is called a hexagon. That makes this a hexagonal pyramid. Hexagonal pyramid. Okay, take a look at the next one. All right, I see that I have triangles all around and everything comes to one point up at the top. This is also a pyramid. And when you look at the very bottom of this pyramid, this one base that we have, this is a triangle, right? So that makes this a triangular pyramid. So this is what I mean by the shape of the base helps you to name it. So step 1, is it a prism or a pyramid? Step 2, look at the base. Name that base. Sounds like a math game show just waiting to happen. All right, take a look at this one. I see that we have lots of little rectangles around the side. I want to see 2 identical bases, which I see here and I see here. Those are the bases. So 2 identical bases means this is a prism. I want to know what kind of prism, so I'm going to count the sides of this polygon. There's 1, 2, 3, 4, 5. A 5-sided polygon, that's a pentagon. So we're going to call this a pentagonal prism. Pentagonal. Okay. This one kind of looks like it fell over a little bit, and this is like the prism I was telling you initially. It's not always set up where the top and the bottom look like they're on the top and the bottom. This I can see, this is a rectangle. There's way more than 2 of those rectangles, right? I'm looking for 2 identical bases to know if it's a prism. And I see that this and this, those are identical bases. There's 2 identical bases. That makes this a prism. Now take a look. How many sides does the base have? Pick one of them. It doesn't matter. And maybe instead of tally marks, maybe you want to do, just draw your line around. So 1, 2, 3, 4, 5, 6. Or maybe you want 1, 2, 3, 4, 5, 6. However you want to do it. There's 6 sides to it. We already talked about what that's called. A 6-sided polygon is a hexagon. That makes this a hexagonal prism. So when you look at the pyramid, the hexagonal pyramid, one base, they all come to a point. In the hexagonal prism, I have 2 identical hexagons. And then it's closed up with a bunch of rectangles, a bunch of parallel, lateral faces around the sides. All right, we have one last one on this sheet. Yes, I know there's more. Okay, I see a whole bunch of triangles. I don't see 2 of anything that match. I see one base with everything coming to a point on the top. That means pyramid. And to know what kind of a pyramid, 1, 2, 3, 4, a 5-sided polygon on the bottom. Yup, 5-sided means a pentagon, so this is a pentagonal pyramid. Alright, so hopefully you enjoyed Name That Shape. Now I'm going to show you how to draw some 3D shapes. I know some of you are excellent drawers. This is your thing. You're going to love this. Some of us are going to say, when is this chapter going to be over? I have the hardest time with this. I also had a hard time with this back in the day, so it doesn't mean that you can't get it if you're struggling with it a little bit. I am here to help you. So is Mrs. Sullivan. We're a great team. We're going to draw some prisms first. Okay, again, just to forewarn you, these are things that don't come naturally to Mrs. Trombley. I'm going to do my best in assisting you. Okay, so if you're drawing a prism, we know that a prism has 2 identical bases, right? So your step 1 would be to draw 2 identical bases. Then all you have to do is connect the corresponding vertices, connect the points that would match up. Change any hidden lines to dashed lines. So example 1, I ask you to draw a rectangular prism. Okay, so we see the word prism. We know that means we have 2 bases that are identical, and it's a rectangular prism. That means the bases are rectangles. So when I say draw 2 identical bases, I mean draw me a rectangle. And now kind of up and over a little bit, draw another rectangle that's identical to that one, as close as you can get. Just do your best. Okay, so that's step 1. Now I say connect the corresponding vertices. So do you see how this is lined up with this one? Those are in the same place. Those are corresponding vertices. So we're going to connect those. This one and this one also match up. Connect them. Bottom, bottom, those match up. And bottom, bottom, those match up. So we've got all the corresponding vertices connected. And the last step says to change the hidden lines into dashed lines. You're going to have a pencil that you're writing this in. I have to write in pen or you can't really see it when I'm doing these lessons. So what I would do now is flip over to the eraser side of your pencil, and where I draw dashed lines, you just are going to erase. Guess you can't see with my whole big hand in the way. You're just going to erase little sections of the dash. I'm going to go over it with a darker pen. So if this box were setting in front of you and you're looking at it from here, you wouldn't really see this line. You wouldn't see inside there, and you wouldn't see inside there. So we've got some dashed lines going on inside to represent those pieces that we wouldn't see. We would only see them if the box was see-through. Alright, so again, just take your little eraser. You can erase little sections. If you drew the box and the dashed lines are giving you a hard time, just be proud of yourself for drawing the box. We'll work on the dashed lines later. It's not that big a deal, I promise. Okay, one more prism, just to make sure, because I don't think one example is ever enough. I'm sure you know that from class. Alright, so a pentagonal prism. It's a prism. That means I'm going to have 2 bases. It's a pentagonal prism. That means the bases are going to be pentagons. Yes. So right now, we have to draw 2 pentagons. Pentagons have 5 sides. Again, do your best. I'll try to do my best too. I'm scared. I'm writing in pen. 1, 2, 3, 4, 5. Alright, there's my pentagon. I want to draw another pentagon. I'm going to draw it up and over from there. I want it to be the same. Okay, 1, 2, 3, 4, 5. Yay, I'm so proud of myself right now. There's the base, or bases, sorry, 2 bases, pentagon. Now I'm going to do the same thing. I'm going to connect the corresponding vertices. So those 2 are located in the same spot. We'll draw a line connecting them. The tops, those are in the same spot. Connect them. This, those are located in the same spot. Connect them. Here and here, same spot. Connect them. And here, same spot. Connect them. So we have our lovely little 3D shape drawn. I know, kind of tricky. This little line's bugging me a little bit, but I'm just going to try to let it go. Okay, there we go. Now I want to connect, or I'm sorry, I want to draw little line segments for the ones that you wouldn't see. If you were looking at this and it wasn't see-through, I wouldn't see this line here, or this line here, or that line right there. But all the rest of them, we would end up seeing. Okay, so the prisms are out of the way. Now we're going to draw some pyramids. With a pyramid, I think it's a little bit easier, personally. It says draw the shape of the base. There's only one base, right? And then draw a point above it and connect all the vertices of the base to the point. And then we'll, again, change our hidden lines to dashed lines. So if I am drawing a triangular pyramid, that means I have one base because it's a pyramid, and that base is going to be a triangle. So draw a triangle. Voila. I know it could be better. I'm trying. Okay, there we go. Now you can see it. Yes, you agree. I'm sure it could be better. So we drew our triangle. Now it says that we want to draw a point above it. So I'm just going to draw a point up here. And we're going to connect the vertices of the base to that point. So there are my vertices. I'm going to connect them to that. And then I want to hide some lines. So if I was looking at this, honestly, I would just see the big triangle in the front if I was looking at it. And we'll talk about a bird's eye view in a moment here. But all of these lines inside here would end up being hidden. The front is what we would see, depending on how we look at it. All right, one more of these. Draw a rectangular pyramid. So if it's a rectangular pyramid, pyramid means one base. Rectangular means that base is a rectangle. Okay, so let's draw a rectangle. Forget about those little lines. Just pretend they didn't happen. I can pretend. We're going to draw a point above it. And I'm going to connect all these corners, all the vertices, to that point. So we'll play a little game of connect the dots. Oh, I don't like writing in pen. I wish you could see with pencil on the notes, but alas, it does not happen. All right, when you look at this, you're not going to see underneath here. We might be able to see those sides, so I think that would probably be the only one hidden, depending on the size of this thing. So that's that. When you're drawing a prism, you draw the 2 bases and connect all the corresponding vertices. With a pyramid, you draw the 1 base with a point up on the top and connect all the vertices to that point. One last little portion to go. We're almost there. I want you to be able to draw different views of a salad, because when we're trying to unwrap some things later on during the whole surface area calculation portion of this unit, it's going to be helpful for you to be able to understand what these things actually look like. So drawing views of a salad. I want you to look at each shape kind of from a bird's eye view in all 3 directions. And I say bird's eye because when a bird's flying directly above your head, be very careful, all right? That could be dangerous. I'm sure you're like, why? Oh, yeah. Just because cows don't fly, that would be a mess. So bird's eye view. If the bird was right above your head looking down on you, it's not going to see your entire body. It's going to see kind of just the top of your head and aim for it, I'm sure. So we're pretending that we're just looking at these angles. Here we have a cone, right? I know this is a cone. There's a 1 circle base. They come to a point. If you were just looking at this cone from the front, I want to know what would it look like. So I have a cone here. I cut it all out. Yep. That's what I do in my spare time. When I am looking at the cone from the front, what shape does that look like? Yeah, it looks like a triangle, right? So draw yourself a little triangle. From the side, yeah, it doesn't really have a better side, does it? Which side looks better? They both look like triangles to me. And if you're looking at this from the top down, okay, what shape do you see looking at from the top down? Don't you just see it's supposed to be a circle? I didn't do that great with my cutout. Maybe if you looked at it from this way, it would be better, because again, are you looking at it as a party hat? Or, I have highlighter all of my hand, I see, are you looking at it as an ice cream cone? Either way, when you're looking at this from the top, all you see is a circle. Alright, let's try another one. I think the shape helps. You're going to be creating some of your own shapes to have, so you'll be able to look at them. It should be very helpful. That's what I'm hoping for. Okay, next here, we have, this is a pyramid, right? It's a rectangular pyramid. I can tell because there's a rectangle in the bottom, and it's coming up to a point. So I have one right here. I cut it out. It was really fun. If you're looking at this from the front, what do you see? Yes, there's a triangle there. So draw a triangle. If I'm looking at this from the side, what do you see? It's a triangle again. Now, if you look at this from the top, what are you actually seeing? Yes, I know this one looks like a square, but in the picture it's kind of a rectangle, so you could say a rectangle or a square. And if I had it like this, it's easier to see, but that's all you're going to see when you're looking down on this. So top view of this, I'm going to say rectangle, so we'll just draw what we see. That's what we would see. Okay, last one, and then yes, we're done. I know, it's a little bit longer than normal, but it's 3 pages of stuff. I think I did okay. All right, so here we have a cylinder. I know it's a cylinder because I have 2 identical circular bases and 1 lateral surface. So I couldn't find I couldn't cut out the cylinder. I tried really hard and I had a hard time. But I did find my son's Flarp noise putty. If you've never used this before, it's very entertaining. But this is a cylinder, right? Okay, so here we go. Yep, see, cylinder. If you're looking at this from the front, this should look like a rectangle to you if you're just looking straight on. And if I go like this instead, still the shape of a rectangle, right? 4 sides, top and bottom are the same, 2 sides are the same, parallel. So again, same thing. When you look at this from the top, what do you see? No more rectangle. I see a circle. So draw yourself a circle, pat yourself on the back, and go have an ice cream cone. You're done.